In this lecture, we're going to work on the move action from the gameplay action map. Before we do, we must understand the concept of composite binding. Thus far, we've been using regular bindings. They're perfect for actions that require a single button press. But what if we need to support multiple button presses? For example, let's say we were developing a text application. Most modern text applications support copying and pasting. The most infamous keyboard shortcuts are Ctrl-C and Ctrl-V. Listening to a combination of key presses is common for application and game development. Unity refers to this feature as composite binding. They are bindings with two or more buttons for triggering an action. Best of all, we can make it optional to trigger an action with two buttons. But why would we want to use a composite binding? Let's imagine the player is a green circle. Similar to our game, this circle can move with the W, A, S, D keys. The W key moves them forward. The A key moves them left. The S key moves them backward. Lastly, the D will move them to the right. It's a traditional setup for a game. Players won't always move in these directions. They may want to move diagonally. For example, they may want to move with the W and A keys simultaneously. This key combination should move them in a diagonal direction. Without composite binding, creating this feature would be difficult. It wouldn't be impossible, but it can be a challenge to implement. Why go through the hassle when composite binding handles most of the work for us? Composite binding was created for scenarios like these. Let's try updating the move action. For the Input Actions window, select the Move action from the Gameplay action map. Next, set the Control Type field to Vector 2. Before adding the bindings, we must specify the control type. The control type configures the type of value that will be produced by our binding. Composites are capable of producing vectors. If you're not familiar with vectors, they're a mathematical concept. We aren't going to dig deep into the definition. Just know that Unity uses vectors for the position of a game object. Once we start moving the player, you'll be able to get an idea of what a vector is. The Vector 2 type is for moving objects on a 2D plane, whereas Vector 3 types will move objects on a 3D plane. So why are we using Vector 2? Let's head on over to our game. From the hierarchy, focus on the Player Placeholder Game object. The goal of this section is to move the player across the map. By the end of it, we should be able to move them across the X-axis and Z-axis. But what about their Y-axis? Unlike the other axes, players will not be able to move across this axis. Diving and jumping will not be featured in our game. Therefore, we don't need to produce a 3D value. It'll be easier to work with a 2D vector. Let's head back to the Input Action window. After setting the control type, click the plus button for the move action. As mentioned before, the first option will create a regular binding. The other options create different types of composite bindings. Unity provides us with templates to help us build custom composite bindings. In fact, it's common to create a composite binding for moving the player on a 2D plane. Select the Up, Down, Left, Right composite option. Next, we can assign a name to our composite. Let's change the name of the composite to Keyboard. After doing so, we can start setting the paths for each binding. Let's quickly go through them. It's nothing we haven't done before. For the Up binding, set the Path field to the W key. Next, for the Down binding, set the Path field to the S key. Afterward, for the Left binding, set the Path field to the A key. Lastly, for the Right binding, set the Path field to the D key. Great! We've successfully added a composite binding to the move action. The rest of the settings can be left as is. We're finished with the actions for our game. It's time to start writing code. In the next lecture, let's begin moving the player with these actions.